Hello, hello everyone. Welcome to the Math Tutor channel. Today we are going to introduce a new topic. You can call it a new topic that has been in the field for months. I mean for some time, rather. Sorry about that. Yeah. So we are going to talk about differentiation. Okay, differentiation. Okay, differentiation is part of a big branch called calculus. Calculus has two basic branches, differentiation and integration. These two are related, okay? They are related, but today we are going to talk about differentiation. Differentiation has been used in everyday life, real world situations. For example, in designing aircraft wings, in studying radioactive decays, population change, and also the most recent one, like the most known one, like people are so experienced in this, is modeling the financial world. You've heard of what is happening in the economy. So, things to do with economics and designing those rates and everything, they use differentiation. Okay, yeah, so differentiation is the rate of change of a quantity, so how different quantities change in relation to time. We call that differentiation. Okay, so let's start with notation. How is this word represented in math or in science? So differentiation, instead of writing differentiation, we can write this, okay, or we can write this. Okay, these two symbols mean this word, differentiation. Okay, okay, so let's start with the rules. Okay, the rules. So the first rule is called the power rule. How do we deal with powers when we are differentiating? So if y is equal to x to the power of n, okay, if y is equal to x to the power of n, so dy dx will be n to the x to the power n minus 1. Okay, so this here will be called the derivative. Okay, just like the answer you get after multiplying two numbers is called a product, the answer you get after differentiating a function or an equation is called the derivative. Alright, I hope that you're understanding this. Okay, we shall talk about an example quickly and see how that rule applies. Okay, so it's called the power rule. Okay, yeah. So an example can be find, this is how they can ask you, find the derivative of, okay, then we can say x to the power of 7. So using the power rule, dy dx will be 7x 7 minus 1. So the derivative will be 7x to the power of 6. Okay, so that is how it can be solved. We can look at another one, 1 over x squared. You can say dy dx is, remember indices, how you studied indices, so this is the same as x to the power of, this is the same as x to the power of negative 2, so negative 2 comes down here, then negative 2 minus 1, so dy dx will be negative 2, okay, x to the power of negative 3, or you can say negative 2 over x to the power of 3. Okay, so this is the derivative. Okay, okay, let's try one more. Let's try 1 or 2. So f of x is equal to the root of x. So this is exactly the same as y is equal to the root of x. Okay, so we can use the other term x function, the derivative of root x means x power half. So the derivative dy dx, or the function complement x will be, or f inverse of x will be a half x power a half minus 1. Right? So the derivative of the function x will be half x to the power of negative half, or you can say the answer is 1 over 2 square root of x. Okay, so this here can be the answer. And then I hope you're understanding. How about if they say this: find dy dx of y equals x. Look at that. Beg your pardon? No, y equals 2. Find. Okay, so when we are solving this, we would say y is equal to 2 is the same as y equals to x to the power of 0. Remember, any number to the power of 0 is 1. Okay, so dy dx will be 2 times 0, the 0 comes down here, remember, and then x 0 minus 1. Alright, so 2 to the power of 0 is 0. Okay, so 0 into x to the power of negative 1, and any number times 0 is 0, so dy dx ends up being 0. Alright, so I hope the power rule is okay, and I hope you understand this. So I'll get you some quick ones that you can try out. Okay, you can try out this. Find dy dx, and then example, it can be y equals x power 4, or y equals x power 9. This is 1, 2, and then 3. You can say that y equals the cube root of x squared. Remember, this is you can work it out from the indices. Okay guys, so see you in differentiation part 2 as we continue with the rules of differentiation. I hope this was helpful. We started by looking at the meaning of differentiation and how it is applied in the real world, how it is represented in science. Remember, differentiation can be used in math and science, other science subjects, like other science branches like chemistry, biology, physics. And we have looked at number 1 rule, that is called the power rule, and how it is applied to different questions. Alright, so I hope this was beneficial. I hope you understood, and I hope you start practicing with differentiation. So see you in my next video, where we shall look at other rules of differentiation. Bye bye.